my dear students, welcome to IMS Academy Gate Score Booster session on communication subject. So in the last class we have discussed variety of questions regarding the first chapter and second chapter, right? So in the last class I have given 2 homework questions. So whoever tried by this time, all of you can share your answers in the comment section. In the chat section you can mention your answers. Whoever attending very first time regarding Gate Score Booster session, no issue at all. I will show those 2 questions now, okay, one by one. I will give some time for all of you. After that I will discuss those questions, okay. Yeah, good evening Thiru. So I am welcoming all of you for today's session, and this session is also common for 2 branches, EC and instrumentation. So all of you kindly share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this particular session, right? So whoever missed the earlier session, no issue at all. That particular lecture is available in our playlist, in our YouTube channel. In the playlist you can go through regarding Gate Score Booster communication part 1, okay. So kindly watch that session in your free time, okay. So in this particular session we are going to discuss the questions from second chapter and then remaining chapters also, okay. So I hope all of you are eagerly waiting for the session. So let us start. So this is the question I have given as a homework in the last class, okay. Whoever tried by this time you can mention your answer. Whoever seeing this question very first time, no issue at all, okay. I will give some time now so all of you can try, okay. This question is based on frequency modulation, especially wideband frequency modulation, okay. So in this particular question, here it is mentioned you are having the carrier signal and message signal, okay. Message signal is a sinusoidal signal which is having the amplitude AM and frequency is FM, and regarding the frequency of the message signal it is mentioned as 1 kHz, and here in this particular experiment the AM value they have varied starting from 0 volts and then they are increasing, okay. Now it was found that the carrier component in the spectrum is reduced to 0 for the first time when AM equal to 2 volt. So with the help of this data and given data, so try to consider, say for example, when you are having in the wideband frequency modulation you will be having spectrum up to infinite, okay. So here in the wideband frequency modulation spectrum, okay, at for some selected beta values at the carrier frequency the signal component or signal strength will become 0, okay. So first of all consider those beta values. Among those beta values, whichever beta is the starting beta value for which the carrier signal component will become 0, that beta value consider and try to find out the frequency sensitivity, that is KF, okay. So after that you can consider that KF, and here you have to find out the AM in such a way that the carrier component will be reduced to 0 for second time. That means you have to consider the next beta value at which the carrier frequency is going to, at carrier frequency the signal strength is going to be 0, okay. So by considering that beta value and by considering this KF, try to calculate the AM. That is the question. This is a conventional question. So in the first case you have to calculate KF, that is frequency sensitivity. In the second case you have to calculate the amplitude of the message signal. All of you give it a try. I hope all of you understood the question. So just recall the beta values for which at the carrier frequency the signal component become 0. Among those beta values, for finding frequency sensitivity you have to consider the first beta value, whereas in second case in order to find the AM you have to consider second beta value. So all of you give it a try. Yeah, time up. So this is a very interesting question. That's why I have mentioned this particular question in the conventional approach instead of MCQ or MSQ. Okay, this is a very beautiful question. So first of all, you note down the beta values. Okay, you try to remember starting 3 beta values or 4 beta values at which the at the carrier frequency the signal component becomes 0, right? So first of all, you can note down the signal strength at carrier frequency will be 0 for, can you recall for which beta values the signal strength at carrier frequency will be 0? Yeah, good evening Rakesh. So all of you can mention for which beta values the signal strength at carrier frequency will be 0. Yeah, for beta equal to 2.4, beta equal to 5.5, beta equal to 8.6 and beta equal to 11.8. Like that you will be having various beta values. Okay, at those selected beta values the signal strength at carrier frequency will be 0. Okay, try to remember the first 3 beta values or 4 beta values. Okay, now in the question if you read here, they have given AM we have to calculate. Okay, so in the first case AM value they have given 2 volt, FM value it is fixed 1 kilohertz, right? Now we have to find out the frequency sensitivity. Here the condition is first time the carrier signal component value become 0, right? So first of all write beta formula. Beta equal to delta F by FM. Beta equal to delta F by FM, where delta F is nothing but KF into AM divided by FM. KF into AM divided by FM. So this is the modulation index formula, right? So first we are solving the question in case 1. Okay, in case 1 beta value we have to consider 2.4. KF we have to calculate. So in case 1 it is mentioned AM equal to 2 volts. The amplitude of the message signal is 2 volts divided by frequency of the message signal given as 1 kilohertz, right? So here 2 1.2 times. So just do the cross multiplication. From here we are getting the frequency sensitivity, that is KF. KF equal to 1.2 kilohertz per volt. 1.2 kilohertz per volt. So here if you observe, here beta you are having, okay, KF is there, and then beta anyway it is a constant, Here AM units are volts, FM units are hertz, but here you got kilo, so accordingly you got. Okay, so when you are bringing frequency term here and amplitude term here, so you are getting the units as in the order of hertz per volt, because here you are having kilo, so you are getting in the order of kilohertz per volt. That is the frequency sensitivity. So as of now we got, for first case we have to calculate the frequency sensitivity. The answer for this question is 1.2 kilohertz per volt. Now we have to consider this frequency sensitivity, and we have to find out the AM in such a way that, okay, we are further increasing AM value. Okay, we have to calculate the next AM value in such a way that the carrier component will be reduced to 0 for second time. So that means we have to consider next beta value. So here next beta value is 5.5. So you can use same formula, beta equal to KF into AM by FM in the same formula, but we are considering modulation index, beta equal to 5.5. which is equal to kf. Just now we got 1.2 kilohertz per volt, 1.2 k. Okay, next am we have to calculate, divide by fm value same, fm value is same, that is 1 kilohertz, 1 kilohertz. So here kilo will get cancelled, right? Bring 1.2 to the left hand side, it will come into the denominator. So from here we can write am equal to 5.5 divided by 1.2. All of you do the simplification and tell me what is the answer. All of you can mention your answer in the chart. .5 divided by 1.2, you will get 4.58 volts. 4.58 volts. I hope all of you are getting the same answer, 4.58. See, in this question, since you are having two questions, in case 1 we have asked to calculate frequency sensitivity, in case 2 we have asked to calculate am. Okay, but suppose in this question if they don't ask regarding directly kf, if they ask regarding directly case 2, okay, so just by observing this formula, here you are having beta equal to kf into am divided by fm, kf into am divided by fm, right? So in this particular experiment they are varying what? Only amplitude of the message signal. They are increasing from 0 volts onwards. Okay, so whenever you are using one fm, obviously here in this experiment they have kept fm is constant. Okay, so obviously kf is also constant. Okay, kf is nothing but frequency sensitivity. Okay, right. So here what will happen, since kf and fm both are constant, okay, so if you are increasing am, so accordingly the beta also will increase, correct? If you are increasing am, accordingly the beta also will increase, right? So in case 1, whatever here we have discussed with respect to case 1 and case 2. Now instead of case 1, if you are asked in the question directly, you are supposed to calculate am for the second time, okay, so that time what you can do, you can consider regarding case 1 data. Okay, so when you are having beta value, say for example here from this formula you are getting like beta is proportional to am, okay. So with respect to case 1, when you are having beta value 2.4, that time the corresponding amplitude of the message signal is 2 volts. That data they have already given, yes or no? They already given. Now according to case 2, you have to consider beta value how much? 5.5. So for 5.5 you have to calculate the corresponding amplitude of the message signal, right? So for 2.4 you are getting 2 volts, for 5.5 how much voltage? Okay, so just do the cross multiplication, that's all. From there you will get, okay, so this value is nothing but 5.5 into 2 divided by 2.4. So here 2 how many times? 1.2. See, now you can observe 5.5 divided by 1.2, same answer, right? So finally you will get the same answer, that is 4.58 volts regarding the am. This is method 2. Whatever we have explained here, this is the method 1. Here regarding case 2, method 1. Regarding case 2 only, method 2, directly instead of calculating kf. Okay, for calculating am of case 2, kf is not at all required, because in case 1 since we asked to calculate kf, that is the reason we have solved. Okay, yeah, other students also please comment whether audio is clear. Yeah, we will cross check, just wait. all of you please respond whether audio is clear now. All other students also please comment regarding the audio. Is it clear? Yeah, fine. Okay, so here since I asked you to calculate with respect to case 1 and case 2, that is the reason first I have solved in the conventional approach. The moment if they are asking to calculate regarding AM in case 2, this is a shortcut method. This is a shortcut because KF is the constant, FM is the constant, only AM is the variable, and beta and AM are directly proportional. So just to do the elementary calculation, that's all. Okay, this question is actually, when you look at the question, it seems to be like very lengthy question because of here if you observe the question, just by looking at the question you will feel that it is very tough or lengthy question to solve. Okay, but once if you, whenever you are having the questions regarding communication system subject, so generally when compared to other subjects, some of the questions regarding communication, okay, it look like very lengthy. Okay, but of course some questions definitely it will take more time for solving the question, but some questions, the question, when you look at the question, it seems to be very lengthy, but once if you read the sentence by sentence and what is the given data, what we are supposed to calculate, once if you recall the concept, and what are the basic formulas that we are supposed to use for solving that question, once if you are able to recall some of the questions initially you may feel that is a very big question, but once if you start solving the question, then from there you are getting the hint. Okay, you can easily solve the same question in less time. Okay, so don't underestimate that communication, all the questions it will take definitely more time. Okay, it's not like that. Some of the questions definitely will take time, but some of the questions you can easily solve in less time. Okay, right. So I hope all of you got the clarity regarding the shortcut method for case 2. Okay, I will discuss. I have given one more homework question in the last class. That question also I will discuss. Okay, so before discussing that question, I am going to announce that regarding our live online program at our IMS Gate Academy, whoever targeting for GATE 2025 or 2026 at our IMS Gate Academy, we are having live online program. So whoever sincerely want to start the preparation for GATE 25 or 26, so all the students, they can book the free counseling session regarding this particular link already provided in the description, right? So you, whatever the details regarding this live online program, complete details you will get. Okay, so our counselors will give the complete information regarding our live online program. So for the time being, I am mentioning our features regarding this particular program. I am mentioning the features. So here, whoever enrolling for live online program, all the students are getting more than 800 hours regarding live classes. Okay, so here all our faculties will discuss each and every concept from basic level to the application level, and we will discuss regarding each and every concept. We will discuss the basic questions and then medium level questions and then advanced level questions. Okay, we will discuss the practice questions and gate questions as well, right? And for all our enrolled students, we are going to provide for every subject, we are going to provide theory book, we are going to provide exercise book. In this exercise book, you will be having 3 levels. In each level, generally you will be having 20 questions. If the chapter is having less weightage with respect to GATE exam point of view, then only in that particular chapter you will be having 10 questions per level. Otherwise, most of the chapters you will be having in every level 20 questions will be there. And if you are solving all those questions, definitely you will get good command over the concept and method of solving. Okay, and in addition to theory book and exercise book, we are going to provide GATE question bank, which consists of 30 plus years, right? So here in our GATE question bank, the specialty is based on the possibility. Okay, wherever required, we have provided the alternate solution and we have provided the important points as a note. Okay, key points. And so with the help of that, whoever solving the GATE questions from our GATE question bank, they are getting the more knowledge regarding the concepts, they are getting the clarity over the concepts, and they are getting confidence by in order to solve the gate questions. Okay, and in addition to these books, we are going to provide online tests. Together we are having more than 130. So here for every chapter we are having one chapter test, and similarly for every subject we are having basic level test, advanced test, and then multi-subject test. After that we are going to provide all India mock tests as well. Okay, so all the students whoever enrolled for live online program, they will get more than 130 plus tests. So whatever the learnings, whatever the concepts you are learning or problem solving, you are gaining the knowledge during the live classes, during your practice. Now if you want to check your confidence, whether whatever the preparation you have done, whether it is up to level or not, whether you have to revise any concept further, you will be come to know while you are practicing these tests. Okay, so all these tests will help you in order to become further improvement wherever you may be doing some silly mistake, or wherever you are stucking regarding any particular question while you are solving, you are getting the opportunity that what are your strengths, what are your areas you need to improve. Okay, all these tests will help you in order to increase your marks in the upcoming tests. Okay, and in addition to that, in our IMS Gate Academy, we are going to provide my plan sessions. Okay, total we are going to provide 12 my plan sessions. Each and every student whoever enrolled for live online program, they can book one slot. Okay, in every month on an average. Okay, they can get the proper guidance and study plan with the corresponding mentor. Okay, so this is one of the unique feature at our IMS Gate Academy we are providing for all our live online program enrolled students. Okay, so kindly share this valuable information with all of your friends and juniors whoever targeting for gate 25 or 26. Okay, right. And this is our Telegram channel, IMS Gate Academy Telegram channel. Regarding this particular link also, it is provided in the description. So if you not yet joined our Telegram group, so kindly join this group in your free time. Okay, so if you are joining our Telegram group, what are the benefits that you are going to get? Say for example, currently Gate Score Booster session is happening in our YouTube channel. It is free for everyone, right? So like that, whatever the upcoming lectures are there, so you will get the updation in our Telegram group. Okay, and here the faculties, after they are discussing, okay, in all the live lectures, okay, after the session over, whatever faculties will write on this digital board, that particular lecture notes we are providing in the PDF form, we will share in this Telegram group. Okay, and whenever we are conducting any seminars or webinars, regarding those updates we will share in our group, in this Telegram group. And similarly, whenever government job notifications or PSU job notifications, that also we will give the update, we will share those updates also in our Telegram group. Okay, and not but not the least, we on daily basis we are providing one quiz question, so all of you can actively participate and you can check your confidence and you can check your knowledge. Okay, and the very next day our faculty will provide the solution for the yesterday question. Okay, so you can go through that solution part. So in that way, on daily basis you are learning one question. It's like question of the day or quiz question, right? So on daily basis you are getting one unique, one great opportunity, right? So on daily basis you are learning something new, right? So in this way you are getting lot of benefits. So kindly join our Telegram group if you not yet joined, and similarly share this valuable information with all of your friends and juniors. Okay, so now let us proceed. This is one more homework question that I have given in the last class. This question related to the AM and FM receivers. This is the question related to the third chapter. Okay, whoever tried by this time, so kindly share your answer. Kindly you can share your answer in the chat. Okay, whoever not yet tried and whoever seeing this question very first time, no issue at all. Now I am going to provide some time, so all of you can try. very interesting question regarding the image frequency. So all of you just go through the basic formulas regarding superheated and receiver. So with the help of that, you can solve this question. Generally in the GATE exam, in some questions they will ask intermediate frequency, or in some question they will ask image frequency, etc. But in this question, instead of asking directly image frequency, so just for keeping some suspense, okay, just in order to make some twist, okay, so I have made the question like this. It is a very interesting question. Yeah, time up. Whatever the answer you got, you can mention in the chart. So this is the question based on superheated and receiver. So the incoming signal frequency of superheated and receiver is 750 kHz. So whatever the signal that is incoming for your superheated and receiver, that particular signal frequency is nothing but Fs. Okay. So here you can note down the incoming signal frequency to your superheated and receiver is nothing but Fs. So in this question it is mentioned 750 kHz. Fs equal to 750 kHz. Right. Now, if the local oscillator is tuned to the frequency of 1000 kHz, 1000 kHz. So the local oscillator frequency is 1000 kHz. 1000 kHz. Okay, now you know the incoming signal frequency, you know the local oscillator frequency. With the help of these two, can we calculate intermediate frequency? Yes, we can calculate. So the intermediate frequency I am representing as F suffix IF, which is nothing but the difference of these two signals. Okay. So here in this case FL is greater, Fs is smaller, so that means FL minus Fs. So 1000k minus 750k, 1000k minus 750k, so that is nothing but 250 kHz. 250 kHz. So this is the intermediate frequency. This is the intermediate frequency. Now let us read the question. Let us read the question further. Then how far the image station or image signal frequency is present from the intermediate frequency? Okay, first of all let us calculate image signal frequency. After that, according to the context, we will answer. Okay. So in this question we have to calculate the first of all image signal frequency FSI, which is nothing but whatever the incoming signal frequency is there, that you have to consider plus 2 times whatever the intermediate frequency you got, that one, 2 times intermediate frequency. So here incoming signal frequency is 750k plus 2 times intermediate frequency, just now we got 250 kHz. So 2 into 250 is nothing but 500. 500 plus 750 is nothing but 1250. 1250 kHz. This is the image signal frequency. 1250 kHz is the image signal frequency. Now the question is, so the moment you got image signal frequency like this, sometimes students will be in hurry mode. The moment you got 1250 kHz, that option is there in one of the option. Okay, that value is there in one of the option, but that is not correct. In the question, if they directly ask what is the image signal frequency or how much image signal frequency you are going to get, in that case 1250 kHz is correct. But here the sentence is very beautiful. Okay, according to the context you have to mention your answer, right? So here how far the image signal frequency is present from your intermediate frequency. Okay, so that means from intermediate frequency how much far. Okay, so what you have to do here, just observe intermediate frequency you are having 250 kHz, intermediate frequency you are having 250 kHz, whereas image signal frequency just now you got 1250 kHz, right? So from intermediate frequency how much far they are asking, right? So you can subtract intermediate frequency from here. Okay, so here image signal frequency minus intermediate frequency, which is nothing but 1250 kHz minus intermediate frequency is 250k. So 1250 minus 250 is nothing but 1000 kHz. So this is the answer. from intermediate frequency, the image signal frequency is having the difference of 1000 kilohertz. Okay, or suppose intermediate frequency is 250 kilohertz. So from there, if you are adding 1000 kilohertz, so at that particular frequency you are getting image signal frequency. Okay, so the answer for this question is 1000 kilohertz. Option A is the correct answer. Option A is the correct answer. See here, why we are calling that is the image frequency. It is very simple. Say for example, so here our incoming signal frequency is 750 kilohertz. Our incoming signal frequency is 750 kilohertz. Okay, 750 kilohertz. Okay, so here in the superheated and receiver we are using mixer. Okay, so mixer will produce the addition of two frequency or subtraction of two frequency. Okay, but in this particular superheated and receiver we are considering like difference of two frequencies. Okay, so here in this case FL value is greater. Okay, in case 1 we are having FL equal to 1000 kilohertz, FL equal to 1000 kilohertz, and the incoming signal frequency is 750 kilohertz. 750 kilohertz. So in this case FL is greater when compared to FS, right? So since FL is greater than FS, in this case we are performing FL minus FS. FL minus FS. Mixer will produce difference of two incoming signal frequencies, right? So here 1000 minus 750, which is nothing but 250 kilohertz. 250 kilohertz, right? So this is our, this 750 kilohertz is our main signal. Okay, but since you are using mixer, that mixer will produce whatever the two incoming signal frequencies you are having, difference of those two, okay, it will produce as the output. Okay, so in this process, say for example here as of now, if you observe image signal frequency I have mentioned like 1250. Okay, so here in this case also the local oscillator frequency we have kept as it is 1000 kilohertz. Okay, local oscillator frequency we kept as it is 1000 kilohertz. Now consider this is, if this frequency is your incoming signal frequency, suppose. Okay, so in that case here FSI, this is what, 1250 kilohertz. 1250 kilohertz. So in this case which frequency is greater? Obviously second frequency is greater when compared to first one. So if you are getting this frequency as the input, okay, that time the mixer will produce, ultimately it will produce difference of two frequency, right? So here in this case FSI is greater than FL. So in this case you are going to get FSI minus FL, which is nothing but 1250 minus 1000, which is nothing but 250 kilohertz. 250 kilohertz. So 250 kilohertz is what? Your intermediate frequency, right? After whatever the intermediate frequency you got, after that we are using IF amplifier. So that IF amplifier will amplify the signal which is having the center frequency 250 kilohertz. Okay, so the 250 kilohertz you are getting because of the incoming signal frequency 750 kilohertz, but this is our actual signal. But the same 250 kilohertz you are able to get with one more possibility, along with 750 kilohertz, suppose due to any reason another channel signal frequency 1250 kilohertz if you are having. Okay, because of that 1250 minus 1000, which is nothing but 250, right? But our required signal which we are supposed to amplify is this one. But in the course of time, if you are getting some other channel signal frequency, okay, if you are having 1250 kilohertz, so that because of that, okay, here difference, in this case this is greater, so difference of these two frequency, once again you are getting 250. That's why we are telling this is our main signal. When compared to this signal, you are getting image signal. That's why we are calling that particular frequency as image signal frequency, right? So in general you can eliminate that one with the help of some tuned circuit, okay, and with the help of image rejection ratio and all. Okay, so we will keep at this particular frequency the more amplitude, and whereas at the image frequency we will keep the amplitude as minimum as possible, almost closer to 0, so that in that way we can suppress this particular image frequency in the real time by using superheated and receiver. Okay, so in this case for 750 kilohertz the image frequency is 1250 kilohertz, like. Okay, so I hope all of you got the clarity. Now let us proceed to the next question. This is a question based on random process, random variables. So in this question, I have mentioned regarding the probability density function, fx of x equal to k. K means constant in the interval regarding x between 3 and 5, including 3 and 5. In that interval only, the probability density function value is a constant. Other than that interval, okay, you are having probability density function as 0. Now you have to choose the correct options. This question is MSQ. Either one option or more than one option can be correct. So here in option A, I have mentioned regarding mean value, option B mean square value, option C variance, option D DC power. So all of you give it a try. So can you identify from the given relation regarding the probability density function, can you identify the name of the random variable or that particular random variable distribution? Can you identify? So you are having special random variables. So just by observing the probability density function, can you guess the given random variable belongs to which case? Yes, it is the uniformly distributed random variable. You can observe here between 3 to 5 you are having one interval or range of values. In that range of values you are having the probability density function constant. Okay, other than that you are having 0. So that means it is uniformly distributed in that particular interval, right, or for that range of values. Okay, so for this question you can easily solve once if you know the standard formulas regarding all of this. Okay, but due to any reason, okay, if you are forgetting the formulas, okay, for that, okay, then you can easily derive during your exam also. Okay, so whoever studying this concept very first time, okay, I will discuss the formulas derivation first. After that we will substitute the given values and from there we can find out the values. Okay, and we can figure out which options are correct. Okay, Yes, very good, Akanksha. Yeah, whatever two choices you have mentioned, those are correct. Okay, so similarly C and D also you can verify. Yes, very good, very good, excellent. Okay, so first of all I will discuss, okay, regarding the formulas I will discuss the derivation. After that I will use those formulas in order to find out the regarding whatever the four choices here you are having, regarding that each and every parameter let us calculate the values. Okay, so just by observing the given function, for the generalized case I am writing, say for example whatever the probability density function they have mentioned. So for the time being we are considering like this, fx of x equal to constant in the interval a and b. They have given the values, but for the time being I am considering a and b. In this interval you are having its values constant, say for example it is k. Okay, so I hope all of you know the standard formula regarding whenever you perform integral minus infinity infinity fx of x dx is equal to 1, is equal to 1. So area under the probability density function is equal to 1, or sum of all the probabilities equal to 1, all are same, right? So here integration is nothing but area under the curve. Integration is nothing but area under the curve. So here if you observe, you are having, when you look at this particular distribution, this particular shape is in which form? Is it rectangle or is it square? So for the time being you can consider like rectangle, because we don't know exact values, right? If you know, suppose horizontal length and vertical length, if both are same, then you can consider like square. Okay, but here since we don't know, so you for the time being you can consider like rectangle. So here for rectangle area is nothing but length into breadth. Here length is nothing but b minus a, and here width or height is nothing but k. So area of the rectangle is nothing but length into breadth. Okay, so from here we can calculate k equal to 1 by b minus c. K equal to 1 by b minus c. Okay, right. Suppose wherever if you don't have the standard shape, and or if you don't know the area of that particular shape, then you can perform the integral by considering the limits here according to the given waveform. Okay, you can consider limits, and from there you can calculate the unknown parameter. Okay, now in option A you are having mean value of x, that means expectation of x, which is nothing but integral minus infinity x into fx of x dx. Okay, here integral limits are a to b. For generalized case I have considered, x I am keeping as it is. Regarding fx of x, here fx of x is nothing but k, where k is nothing but 1 by b minus a. So from here I am writing fx of x equal to 1 by b minus a, in the interval a to b. A lies between, x lies between a and b. Okay, 1 by b minus a. So here 1 by b minus a into dx. 1 by b minus a is what? Constant. We can keep outside the integral. Integral x dx is nothing but what? Integral x dx is nothing but x square by 2. Now you can substitute the limits. Here in the denominator you are having 2 into b minus a. Here substitute upper limit b square minus substitute lower limit a square. B square minus a square is nothing but b plus a into b minus a. B plus a into b minus a divided by 2 times b minus a. Here b minus a will get cancelled. From here you will get either b plus a by 2 or a plus b by 2. So for the timing I am writing like a plus b by 2. Both are same. This is your expectation of x. Expectation of x. Expectation of x is nothing but a plus b by 2. A plus b by 2. Okay. Now substitute A and B according to the given question. A and B are nothing but 3 and 5. A and B are nothing but 3 and 5. So here 3 plus 5 divided by 2. 3 plus 5 is 8 divided by 2, which is nothing but 4. Expectation of x is nothing but 4. Okay. Whenever you are having uniformly distributed random variable, so just take average of those two limits. That's all. Whatever the uniformly distributed variable you are having, it is distributed uniformly from which value to which value. Okay. So just take average of those two values. That's all. Here expectation is nothing but mean. Okay. Whatever the probability density function you are having, from which point, okay, with respect to which point the given distribution function or density function is symmetrical. Okay. Say for example here this is 3, this is 5. So when you have taken average, you are getting 4. So from 4, when you observe to the left hand side, you are having the shape like this. From 4 towards right hand side, you are having the shape like this. It is symmetrical. It is symmetrical, right? So that symmetrical point is nothing but our reference point. We are calling it as the mean. So for this question in option A, mean value it is mentioned 4. Yes, it is correct. But this question is MSQ. We have to verify all the options. Okay. Now let us find out mean square value. Mean square value. Mean square value is nothing but expectation of x square. Expectation of x square. So which is nothing but integral minus infinity infinity x square into fx of x dx. Once again, first I am deriving for generalized case. After that I will substitute the values. Okay. So here limits are a to b. X square into fx of x is 1 by b minus a into dx. Here 1 by b minus a is constant. We can keep outside the integral. Then integral x square dx is nothing but x cube by 3. Now you can substitute the limits. Okay. In the denominator you are having 3 into b minus a. Now substitute the upper limit b cube minus a cube. I hope all of you studied like this equations or formulas in your mathematics subject, right, during your school standard or intermediate. B cube minus a cube, what is the formula? B minus a into b square plus ba plus a square divided by 3 into b minus a. So here b minus a will get cancelled. So from here you are going to get expectation of x square is, okay, I am writing in the like alphabetical order. First I will write a square, then ab, like that order I will write. So from here we are getting a square plus ab plus b square divided by 3. So this is the formula for expectation of x square or mean square value. See here expectation is nothing but mean square value. Whatever the random variable you are having, that random variable we are performing square. After that we are performing the mean of that. Okay, so that is the meaning of mean square value. Mean square value. Okay. Now let us substitute whatever the given values according to the given question. Here a value is 3, b value is 5. A value is 3, b value is 5. Now 3 square is nothing but 9 plus 3 into 5 is 15 plus 5 square is 25 divided by 3. So 25 plus 15, 40, 40 plus 9, 49 divided by 3. 49 divided by 3, right? So to make the calculation simpler, you can write this one as 48 plus 1 by 3. So which is nothing but 48 by 3 plus 1 by 3. So 3 16 times, right? 1 by 3 is nothing but 0.33. So from here directly you can write 16.33, like that you are getting. Okay, so this is the expectation of x square. Expectation of x square. So just cross check. Yes, we are having in option B same thing. Mean square value of x is nothing but 16.33. It's correct. As of now we got two choices are correct. Now we have to calculate variance. what is the variance formula for generalized case? Variance formula in terms of mean value and mean square value, what is the formula you are having regarding variance? All of you mention in the chart regarding variance. Variance of x is equal to, say for example, here expectation of x we got, right? So expectation of x you can consider as m1, it is the first order moment, whereas expectation of x square we got, so this one you can consider m2, second order moment. Okay, so you are having m2 and m1. So by using in terms of m1 m2 you will get the formula as variance of x equal to m2 minus m1 square. I hope all of you are familiar regarding the variance formula, m2 minus m1 square. Now you can substitute whatever m2 we got. Okay, so first of all let us get the generalized formula, because in some questions instead of asking all the three, okay, they can ask only the mean value, they can ask only the variance, right? So that is the sake, first let us get the generalized formula, after that I will substitute the values. Okay, right. So regarding m2, as of now we got a square plus ab plus b square by 3, a square plus ab plus b square divided by 3 minus m1 whole square, m1 whole square. m1 is nothing but average of a and b, a plus b divided by 2, a plus b divided by 2, right? So from here first term you can copy as it is, a square plus ab plus b square by 3 minus, now you can expand this term or you can perform whole term square. So in the numerator you will get a plus b whole square, which is nothing but a square plus b square plus 2ab divided by 2 square is nothing but 4. Now what is the LCM of 3 and 4? I hope all of you can answer. What is the LCM of 3 and 4? 3 and 4 LCM is 12, right? So multiply this overall expression with 4. 4a square plus 4ab plus 4b square minus this numerator term multiply with 3, right? So 3a square minus 3b square minus 6ab. Okay, right. So 4a square minus 3a square is nothing but a square. Next 4ab minus 6ab minus 2ab. 4b square minus 3b square is nothing but b square divided by 12. So a square minus 2ab plus b square, what is the answer? Yeah, thank you Akanksha for your compliment. Yeah, so kindly share these sessions information with all of your friends, okay, so that they also will join these live sessions, and just like you, even your friends or juniors also will get benefited, right? Whoever targeting for 2024. Yeah, thanks a lot for your compliment. Yeah. So a square minus 2ab plus b square. So this is nothing but a minus b whole square, a minus b whole square divided by 12. Okay, so here a minus b whole square, this one if you want you can write b minus a whole square also, because anyway you are performing square. So a minus b whole square or b minus a whole square will give both are same answer. Okay, why I have represented like this? The reason is very simple, because here we have considered what? Uniformly distributed random variable. When you are having x values, okay, on positive x-axis like this, obviously a is smaller when compared to b. That is the reason I have written like b minus c. Okay, otherwise even if you want, here you can, anyway you are performing square, if you want you can remember this formula or you can remember this formula, no problem. Okay, b minus a whole square by 12. So this is the variance formula. This is the formula for variance of uniformly distributed random variable. Okay, now let us substitute the values. Variance of x is equal to, in this question b is nothing but 5 and a is nothing but 3. So 5 minus 3 whole square divided by 12. So 5 minus 3 is 2, 2 square is 4 divided by 12. So 4 3 times, 1 by 3 you are getting, right? So just observe the option C. Yes, we are having same value 1 by 3. If in some time they can convert in normal value just like this, in that case 0.33. Yes, so variance also correct. As of now we have verified option A, option B and option C, all are correct. Now let us verify regarding the last one. DC power they are asking. DC power how we can get? DC power how we can get? Whatever the mean value you got, for that mean value if you are performing square, from there you are getting DC power, right? DC power of random variable x is equal to expectation of x whole square. Expectation of x whole square. Expectation of x we got 4 for this question. So 4 square is nothing but 16. Since it is a power, units are watts, 16 watt. But in this question I have given in option D as 25. So both are not matching, right? So that is the reason option D is not correct for this question. So for this question 3 choices are correct, option A, option B, option C. Okay, whenever you are getting uniformly distributed random variable, once if you know the formulas, see the formulas regarding the constant value, it is very simple. The moment you are mentioning that it is uniformly distributed random variable from A to B, whatever the length here you are having, okay, just take here height as 1 by that length, that's all, 1 by that length, 1 by here length is nothing but B minus A, right? 1 by B minus A is nothing but this height, okay, area under the curve is nothing but 1. Now regarding the average value or expectation of x or mean value, the basic definition is average only, right? So average of these two values, right? A plus B divided by 2. This formula also you can easily remember. Now regarding expectation of x square, some of you may face the difficulty, okay. So regarding this I will give one more hint, okay. So you can remember the variance, B minus A whole square by 12, and regarding variance you know this formula m2 minus m1 square, right? So you can remember the variance formula and you know the m1 formula, okay, and with the help of that you can calculate m2, okay. That is one approach, or whatever the approach here I have discussed, with the help of that approach also you will get, okay. With the familiarity you can easily remember. So here regarding expectation of x square is a square plus ab plus b square by 3, okay. So in this way if you remember the formulas, you can directly substitute the values and you will get the answer. But due to any reason if you forget any formula, no problem at all. Regarding uniformly distributed random variable, you can derive the formula in couple of minutes, in less time only in the GATE exam, okay. No need of hurry, right? No need to get any tension if you are forgetting any formula, okay, no issue, because in communication system subject we are having lot of formulas, right? So based on the possibility, try to remember as many formulas as possible, but due to any reason if you are forgetting any formula, just be strong on the concept. Once if you are strong on the concept, no problem, okay, no matter in the GATE exam you can derive the formula, okay. But those questions you can solve at later point of time during your exam, okay. Yeah, this is the question once again based on the random process concept, okay. The previous question is based on random variable and this question based on random process and autocorrelation function, okay. So in this question I have given the autocorrelation function of the random process x of t as like this, Rx of tau equal to 2 into e power minus tau, and here once again this question is MSQ, you have to choose the correct options, okay. So here I have used the expectation operator, but I have given different expressions or equations here. So whether all these relations are correct or only few of them are correct, so you have to verify, and whichever options you feel correct you can mention in the chart. So for solving this question, if you know the basic formula or basic definition regarding autocorrelation function, with the help of that you can easily answer regarding option A, option B, option C, which are correct, okay. Regarding option D, you have to use like a minus b whole square formula. After that you can do further expansion, from there you can find out, okay. Yeah, this is a very interesting question. Whoever knows the basic formula regarding autocorrelation function, they can attempt this question correctly, but due to silly mistake, some people will choose, okay, wrong options as the correct. Okay, that is the reason intentionally I kept some of the options, okay, intentionally. Whoever do, okay, either intentionally or unintentionally, whoever do, because of the silly mistake, they can guess the wrong option as the correct one. So like that possible options I have kept in some of the given options. Okay, so from these gate score booster sessions, all of you are getting the opportunity that where in general the students will do silly mistakes, you are getting the great opportunity, so that all of you whoever attending our lectures either in the live classes or in the offline means after live session over, whoever watching our gate score booster series, all the students are getting lot of benefit. So all of you are fortunate, you people can avoid such kind of silly mistakes in your real gate exam. Okay, that is main motto of our gate score booster series, in order to increase your marks. Okay, so on the selected topics, whichever most important as for coming gate exam, so regarding those concepts we are discussing the questions. Okay, so that you are getting a good opportunity regarding the formulas, regarding how to solve the questions in the gate exam, and how to avoid the silly mistakes, etc. Yes, Akanksha, just now I have mentioned, yeah, like you people will be there. Okay, so that is the reason, no problem. Here you are attending the class, right? So you are getting great opportunity. Okay, so I always will tell my students that do as many new mistakes as possible while you are learning, because while you are studying any subject, if you are doing more mistakes, okay, that means you are getting some opportunity to learn. Okay, where you have done mistake, if you are identifying, you are getting opportunity to correct it, so that you never do such kind of mistake in the gate exam. Okay, do as many new mistakes as possible, but don't repeat the same mistake. Okay, if you are repeating same mistake, that means there is no use. Okay, right, yeah, don't worry at all. Okay, that is the reason intentionally I already told. Okay, that is why I have intentionally mentioned some of the relations where students can choose the wrong options as correct. Okay, that's why intentionally I kept. And in fact, in the last class also, if you observe, because of silly mistake or because of in hurry mode, whichever options in general students will choose, okay, and because of that mode, okay, they will choose wrong option as the correct one, right? So intentionally that wrong options I will keep in the first choice only. Okay, either option A or option B, so that you people are getting opportunity, so you will be having awareness. Okay, while solving any question in your gate exam, first according to the given data you are solving, but before you are attempting the question, just read the question once again, whether it is correct or not you can verify. If you feel that is correct, you can mention. Okay, so for this question, if you observe, I have given the autocorrelation function. Here in option A, option B, option C, I have asked regarding expectation of x square. Okay, so in order to get expectation of x square, first of all, consider the autocorrelation function. Consider the autocorrelation function Rx of tau. Rx of tau is nothing but expectation of x of t into x of t plus tau. Rx of tau equal to expectation of, you are considering one random process x of t, and you are considering the same random process either delayed version or advanced version. Okay, so autocorrelation function will satisfy for both. In this case, for the timing I have considered like t plus tau. Similarly, if you want, you can consider t minus tau. For that case also it will be valid. Okay, now just by observing here, say for example, just for reference I am mentioning, this is the time axis, this is the time axis. Say for example, at t you are having, this is your t. Okay, so for the timing I am considering t, or if you want you can consider t1 also, no problem. And if this is t, and here you are getting t plus tau, so that means this, the difference of these two instants you are getting tau. Difference of these two instants you are getting tau. Okay, now just observe from this equation how we can get expectation of x square. By considering t value 0 or tau value 0. By considering which value you are considering tau, among t and tau, which one if you are considering 0, so that you will get expectation of x square. Yes, very good Akansha, very good. Yes, very good, excellent, excellent. Yeah, no issue, no issue. So here by the moment if you are considering tau equal to 0, so Rx of 0. Yeah, that's why I have given, okay, I have given the hint. So from this hint you have corrected, right? So that is a very great thing. Yeah. So here tau is different, t is different. T is like time instant. Okay. Tau is tau is nothing but difference of those two time instants. Okay, right. So here when you are considering tau equal 0, then that time you are getting expectation of x of t into x of t, because tau is 0, right? So from here I am writing expectation of x of t into x of t. So this one you can write as expectation of x square of t. See, in the question if they have given directly regarding x of t, then regarding expectation of x square, whatever the earlier formulas we have discussed, like integral minus infinity infinity x square into fx of x dx, okay, when they have given the probability density function, but in this question they haven't given probability density function. So whether we have to use that formula or this formula, from the given data you are getting the clue. Okay, in the previous question regarding uniformly distributed random variable, in that question I have given the probability density function, that is the reason I have used the standard formula. But in this question they have given the autocorrelation function. Since we don't know the probability density function, now we have to just write the basic formula regarding the autocorrelation function. Okay, right. So here, from here you are getting the formula as expectation of x square of t is nothing but Rx of 0. So from here I am just rearranging this formula. Expectation of x square of t, expectation of x square of t is equal to Rx of 0, Rx of 0. Okay, so just for reference, say for example, if I am considering this time instant as 3, okay, so this time instant, suppose if I am considering tau is like, in this case tau is 0, okay, when tau is 0, 3 plus 0 is once again 3 only, like that. Suppose if I consider tau is 2, 3 plus 2 is 5, like that. Okay, right. So expectation of x square of t is nothing but Rx of 0, Rx of 0. Okay, so here t is nothing but you can consider any time instant on time axis you can consider. Whenever you are performing expectation of x square at any time instant, that is nothing but autocorrelation function you have to consider by considering tau equal to 0, by considering tau equal to 0. Now this is the important point. Okay, in general students will do silly mistake. Here tau value we are considering 0. Okay, instead of that what they will do, here I have given 5, they will substitute in place of tau 5. Because of that you may choose option A, but that is wrong. Similarly here I have given 3, you will substitute in place of tau 3, but that is also wrong. Those are not correct. In this case here x square of 5 or x square of 3 expectation is same. Okay, because here just observe, expectation of x square at any time instant you are getting the same value, right? So with this understanding I am writing here. Okay, so expectation of x square of, in option A you are having 5, option B you are having 3. Okay, expectation of x square of 5, expectation of x square of 3, like that they can give any other time instant also. Okay, so that is nothing but Rx of 0, Rx of 0. So that means tau value have to keep 0 in the autocorrelation function, right? So here the given function is 2 into e power minus tau, where if you are substituting tau value 0, e power minus 0 is nothing but 1 into 2 is 2. So directly you can write you are getting 2. So the answer for this question regarding expectation of x square of 5 or expectation of x square of 3 is 2, right? This is very important. That's why if you observe here, I have kept the correct option at the bottom, right? I haven't kept the correct option in the starting. Okay, this is a very interesting question. If you want you can put the star mark for this question. Okay, right. So expectation of x square is 3, expectation of x square of 3 equal to 2, that is the correct. Now let us verify regarding this one whether it is correct or not. Okay, so first of all let us consider this expression. expectation of x of 5 minus x of 3 whole square, expectation of x of 5 minus x of 3 whole square, x of 5 minus x of 3 whole square, right. So here you are having a minus b whole square format, you can expand it, a square plus b square minus 2ab, minus 2ab, right. So expectation operator is the linear operator, because when you recall regarding expectation of x or regarding expectation of x square, right, there we have performed the integration operation, right. So integration operator is a linear operator. So just like that, here you have to perform overall expression expected value. That one you will be getting if you are performing individually expectation. After that, if you are performing linear addition, algebraical addition, okay, wherever you are having addition, you can perform addition, wherever you are having minus sign, so accordingly you can perform the respective operation, you will get the same value, okay. So now I am performing expectation operation among individual. So from there, here you will get expectation of x of 5 whole square, okay, x of 5 whole square, can I write x square of 5, because both are same only, right. X of t is a random process, okay. So here 5 is one time instant, okay. So x of t whole square is same as x square of t, x square of t. Similarly, here expectation of x square of 3 minus, here 2 is the constant, we can keep outside, 2 into expectation of x of 5 into x of 3, x of 5 into x of 3, right. So regarding expectation of x square of 5, x square of 3, just now we got the value is 2. So here you can substitute 2 plus 2 minus 2 into expectation of, say for example, for the timing I am writing this one first, x of 3 into x of 5, x of 3 into x of 5, okay. Why I have written like this, you will come to know now. Sorry, just one second. Here 2 plus 2 is 4 minus 2 into expectation of x of 3 I am keeping as it is. Now this 5 we can write in terms of 3 as x of 3 plus 2, 3 plus 2. Now if you consider 3 is like one time instant, now this 2 will be what? Your tau. If this is t equal to 3, that means t plus tau, right. You are getting a standard format, expectation of x of t into x of t plus tau, which is nothing but autocorrelation function. So here you are getting 4 minus 2 into rx of tau, where tau is nothing but 2, where tau is nothing but 2. Okay, so just for your reference I am mentioning this is t, this is tau. Okay, so rx of tau, where tau equal to 2. Autocorrelation function is always a function of time difference, it is not a function of time, okay. That is the most important point regarding autocorrelation function. So now you can substitute 4 minus 2 into rx of tau, here 2 into e power minus mod tau, 2 into e power minus mod tau, here tau value is 2, okay. So 2 into 2 you are getting 4, 4 minus 4 into e power minus 2. So do the simplification, from there you will get 3.46, you will get 3.46, okay. So 3.46 I have given in last option, yes, it is matching. So for this question 2 choices are correct, option C and option D, okay. So here for the timing I have considered like x of 3 into x of 5, that one I have represented like x of t into x of t plus tau, okay. So for the timing, if you want we can represent this function in another way also, like say for example expectation of x of 5 into x of 3, if you are having like this, okay. In this case 3 we can represent in terms of 5. Okay, so here I am representing like this: expectation of x of 5 into x of 5 minus 2 is nothing but 3. 5 minus 2 is nothing but 3. In this case, 5 is nothing but time instant. 5 is nothing but time instant. Here 2 is nothing but tau. 2 is nothing but tau. So you are getting expectation of x of t into x of t minus tau. That is also autocorrelation function only. Rx of tau, where tau is nothing but 2. Rx of tau, tau is nothing but 2. See, here also you got same. Okay. So I hope all of you know this formula, like expectation of 1 second. Rx of tau and Rx of minus tau both are same, because autocorrelation function is an even function. Autocorrelation function is an even function. Okay. So you can represent Rx of tau as expectation of x of t into x of t plus tau. Similarly, you can represent x of t into x of t minus tau. Okay. Right. I hope all of you got the clarity. So for this question, 2 choices only correct. Now the next question, all of you give a try. In this question, I have given regarding the bandwidth of television signal, that is 4.5 MHz. Here we have used the uniform quantizer, which is having 1024 levels, and sampling frequency in this question we have mentioned that 15% in excess of Nyquist rate. Okay, so you have to calculate the bit rate. Now you can observe the units. Here you are having multiplying factor multiples of 10 power 6 bit per second. Okay, so what is the answer you are getting? You try to represent in multiples of 10 power 6 bits per second, so that whatever the multiplying factor or value you are getting, that one will be the correct answer. Whenever you are having the questions NIT type, whenever you are having the NIT type of questions, if you are having units, just take care about the units. According to the units, you have to mention your answer. Okay. Yeah, this is a simple question based on pulse code modulation concept. Okay, so here in this question, if you observe, a television signal is digitalized using pulse code modulation. The signal bandwidth, see, whenever you are having signal bandwidth, signal means here message signal, right? Okay, the signal bandwidth of the television signal, here in this case they have considered TV, television signal or video signal we can say. Okay, signal bandwidth is same as maximum frequency of that particular signal, both are same. Maximum frequency of that signal, signal bandwidth and maximum frequency of the signal both are same. So here since signal bandwidth they have given 4.5 megahertz, so that one I am considering as FM. FM is the maximum frequency of that particular signal, so 4.5 megahertz. 4.5 megahertz. So this is the maximum frequency of the message signal. In this case, the message signal you are having in the form of video, television, right? Now, here it is mentioned you are having uniform quantizer which is having 1024 levels, right? So the number of levels used is 1024. So in general, the relation between number of quantization levels and number of bits, I hope all of you know this relation, L equal to 2 power n, L equal to 2 power n. So whatever 1024 they have given, try to represent in powers of 2. Here 1024 we can represent as 2 power how much? I hope all of you are familiar. This is a standard value, I hope all of you are familiar. 2 power how much? Yes, all of you can answer. 2 power 10, right? 2 power 10. So now if you are equating both, so 2 power 10 equal to 2 power n, so from there you are going to get n equal to, by comparing these two, n equal to 10. So that means we are using 10 bits for every sample. Okay, for every sample we are using 10 bits. For every sample we are using 10 bits. Okay. Now in this question the sampling frequency mentioned as 15% in excess of the Nyquist rate. This wording is very important. Okay. So the sampling frequency Fs is equal to 15% excess, right? So 15% excess means 15% we can write as 15 by 100 plus, since it is mentioned excess, okay, so 15% plus 1 times Nyquist rate. See, you will get the clarity like this. Now you can observe, suppose if you are multiplying 1 with Nyquist frequency, you are getting Nyquist frequency, and when compared Nyquist frequency you are having 15%, alright. So here 15% of Nyquist frequency excess is there. Okay. So here 15 by 100 we can write as 0.15 plus 1 into Nyquist frequency is nothing but what? I hope all of you are familiar regarding Nyquist frequency. 2 times FM, right? 2 into FM. So here 1.15 into 2 into FM. FM in the question it is given as 4.5 megahertz. 4.5 mega. So here 2 into 4.5 is nothing but 9. 9 into 1.15. How much you will get? All of you please respond. 9 into 1.15. You will get 10.35. 10.35 mega. Here if you want you can represent units are hertz, but since I have mentioned sampling frequency, you can represent samples per second. Both are okay. Okay, mega samples per second. This many samples you are getting in 1 second. Otherwise you can represent simply hertz. Okay, both are same. Right. So 10.35 mega samples per second. Now we have to calculate the bit rate. Bit rate means how many bits we are transmitting in 1 second. That is the bit rate. Okay. how many bits we are transmitting, or you can observe from here also. Here units you are getting bits per second. So how many bits you are transmitting in 1 second, that is nothing but bit rate. Okay. So here bit rate. So if you want, you can represent the symbol as R suffix B. R stands for rate, B stands for bit. RB equal to, see, just observe the units. From the units you will come to know whether you have to multiply or whether you have to perform division. Okay, just observe here. Here you are getting the units are samples per second. Okay, so here our objective denominator term you should have seconds only regarding the units, right? Yes. Here also we are getting denominator term seconds. Okay, but here numerator term you are having sample. Okay, and here if you observe denominator term you are having sample. If you are multiplying these two, sample will get cancelled. Here numerator you are having bits, there you are getting denominator second. Yes, it is exactly matching, right? So you can multiply the number of bits per sample with the number of samples per second, that's all. So here bit rate is nothing but n into fs. Okay, if you know the formula, directly you can write. Even if you are forgetting, okay, no issue at all. Okay, whatever the units you are having, just by observing the units you will come to know what operation you have to perform. Simple. Okay, so here bit rate is nothing but n into fs. So from here you are going to get RB equal to, here number of bits per sample we got 10 into just now we got sampling frequency as 10.35 mega we can write as 10 power 6. Now 10 into 10.35, how much you will get? 10 into 10.35, 103.5, right? 103.5. Okay, just you can shift the decimal place towards right hand side, one digit. Okay, 103.5 into 10 power 6, units are bits per second. So the answer for this question is 103.5. 103.5. Okay, suppose in the NIT question, if they asked only try to represent in the order of bits per second, what is the value here you got, multiply with 10 power 6, after that you will get one integer, right? So that value you have to mention. Okay, but in this question I have represented. If you observe the question, I have asked in terms of, if you want more clearly you can mention into 10 power 6 bits per second. Okay, so that here you will get the answer as 103.5. 103. Next question, all of you give a try. This is a question based on delta modulation concept. This is a very interesting question. Here in this question I have given the message signal like this, and here the question is, in order to avoid the slope overload distortion. I hope all of you know the relation. In order to avoid the slope overload distortion, you are having one important relation. With the help of that relation, here you have to find out the maximum value of the message signal frequency in the order of hertz. Yeah, this is a very interesting question. Whoever tried this question, what is the answer you are getting, you can mention. This is the NIT question, answer will be a number, right? Okay. So in this question, I have given the message signal like this: m of t equal to 3 sin 2 pi fmt plus 4 cos 2 pi fm into t, right, is applied to a delta modulator with sampling frequency. In this question, sampling frequency directly they have given 2000 samples per second. If step size is 2 millivolts, then the maximum value of the message signal frequency will be dash hertz in order to avoid slope overload distortion, right? Okay, so what is the answer you are getting? You have to round off to the 3 decimal places. Okay, this is a very interesting question. So whatever the message signal you are having, first of all write down that message signal, and now if you observe, you are having two terms. You are having two terms. In the first term you are having sine, whereas in the second term you are having cos. Okay, the moment when you observe, sine and cos are like two different terms. Okay, that may be true, but coming to the frequency, if you observe, both are having same frequency. So this is the most interesting thing. So whenever if you are adding two sine terms or cos terms like this, okay, provided if both are having same frequency, okay, then with the help of trigonometric formulas, okay, we can bring those two terms. Either both can be sine or both can be cos, or one is, of course, if both are cos or both are sine, that time you don't have same frequency, because directly you will be having single term. But one term is sine, another term is cos. Okay, but if both are having same frequency, then that one we can bring the two terms into the simplified form. We can bring into one term. Okay, can you guess how we can bring the two terms into one single term? Either it can be in the form of sine or it can be in the form of cos. According to your wish, we can represent either in the form of sine or cos. So in order to bring two terms into the one single term, what operation we have to perform here, so that we will get? All of you think and mention your answer in the chart. This is very interesting. So not only in this question, whenever you are solving any question, even in the network theory subject also, okay, whenever you are having any input signal, if you are just by looking at the expression, when you are having multiple terms, when they are added in terms of sine and cos, if you are having, by looking at sine and cos, you may feel that those are different terms, but that time you have to observe the frequencies, whether both are having same frequency or different. If both are having different, then we cannot bring into the single term, but if both are having the same frequency, then we can bring. Okay. Yeah, some of you are still thinking, right? Okay, no issue at all. Now I will disclose what operation if you perform, we can bring two terms into the single term. This is very interesting. Say for example, here you can observe the coefficients. Here you are having 3 is the amplitude, here 4 is the amplitude. Okay, for the time being you can consider one right angle triangle. Okay, say for example 3 I am considering here and 4 I am considering here. If you want, you can consider any side, there is no issue at all. Here ultimately you are having two terms, each term is having one amplitude. Here 3, 4. For the time you have considered 3 here, here 4. If you want, you can consider 3 here, 4 here, no problem at all. So I hope all of you know the angle here, that is 90 degrees, right? So for the time being I am considering theta here. Similarly, if you want, you can consider theta there, no problem at all, no problem. Okay, so here you know 3, you know 4. Can you find out this value, diagonal value? Can you find out the diagonal value by using Pythagoras theorem? All of you give a try. Here in the rectangle triangle, one side you are having 3, another side you are having 4. Can you tell what is this diagonal length? Yes, it is very simple, right? So here how you can get square root of 3 square plus 4 square, right? A square plus b square. That is the reason I have told you can consider 3 here or 4 here, no problem, right? So here square root of 3 square is nothing but 9, 4 square is nothing but 16, 9 plus 16 is 25, so root 25 is nothing but 5. It is the length of or one side of the triangle. Obviously you have to consider positive value, right? So square root of 25 is nothing but 5. Now for the timing I have considered theta here. So by using this triangle, by using this triangle. Can you tell what is cos theta? Can you tell what is cos theta? And similarly, can you tell what is sin theta? Cos theta is nothing but adjacent by hypotenuse. Here adjacent is 3, hypotenuse is 5. Similarly, sin theta means opposite side divided by hypotenuse. Opposite is 4, divided by hypotenuse is 5. I hope all of you know the standard formula regarding cos square theta plus sin square theta. How much you are going to get? Cos square theta plus sin square theta. How much? You will get 1, right? So all of you give a try whether you are able to get or not. See here, cos theta whole square, that is 3 by 5 whole square, plus sin theta whole square, that is 4 by 5 whole square. So in the denominator, 5 square is nothing but 25, numerator 3 square is 9 plus 4 square is 16. Yes, we are getting same. 25 divided by 25, which is nothing but 1. So from the triangle directly we can find out cos theta and sin theta. Okay. And just for verifying, I have mentioned whether whatever we got, whether it is correct or not. Okay, cos square theta plus sin square theta equal to 1. Right. Okay, right. So why I have done this adjustment, now you are getting a clue. Here we are having only 3, here we are having only 4. But now if you observe cos theta or sin theta, you are having like 3 by 5, you are having 4 by 5. Okay, right. So that means in order to have here denominator 5, since we don't have, in this entire expression we will multiply and divide with 5. Okay. M of t equal to overall expression we are multiplying with 5 and overall expression we are dividing with 5. Okay. So 3 by 5 into sin 2 pi fm into t plus 4 by 5 into cos 2 pi fm into t. Okay, right. So 5 I am keeping as it is. Now for the time being I am writing this term first, sin 2 pi fm into t. Next, this 3 by 5, now we can write it as cos theta, cos theta. Plus, I am writing this term first, cos 2 pi fm into t. Now I am writing this 4 by 5 here. 4 by 5 we can write as sin theta, sin theta. Okay, right. Now 5 I am keeping as it is. Now you are getting one standard trigonometric equation like sin A cos B plus cos A sin B, right? Sin A cos B plus cos A sin B is nothing but sin A plus B, sin A plus B. Sin 2 pi fm t plus theta. Sin A cos B plus cos A sin B is nothing but sin A plus B, sin A plus B. Okay, so just for reference I am mentioning what is the formula I have used. Sin A cos B plus cos A sin B is equal to sin A plus B. Sin A cos B plus cos A sin B is sin A plus B, right? So here A is nothing but 2 pi fm into t, B is nothing but theta. So in this way, whenever you are having sum of two terms, one is sin, another one is cos, provided if both are having the same frequency, we can bring the sum of those two terms into the single term. Now you can observe here, you are getting one single term, okay, which is having the amplitude as 5 and which is having the same frequency fm only, but here you are having some phase angle difference where theta is nothing but, can you tell what is theta here? In this question it is not required, but suppose if you want to find out what is theta, where theta equal to how much? See, you know cos theta, you know sin theta, right? So if you want, you can represent in terms of cos inverse or in terms of sin inverse, otherwise if you want you can represent in terms of tan inverse also. right? So once if you know sin theta and cos theta, from here you can write tan theta also. Tan theta is nothing but sin theta by cos theta, or otherwise opposite by adjacent. So that means 4 by 3. 4 by 3. So from here we can write theta equal to tan inverse 4 by 3. Tan inverse 4 by 3. Or similarly, if you want, you can represent theta equal to cos inverse 3 by 5, or theta equal to sin inverse 4 by 5, or theta equal to tan inverse 4 by 3. Any way you can represent. So for the time being, I am considering tan inverse. Tan inverse 4 by 3. I hope it is clear for everyone. Now, as of now, what I have done, whatever the given message signal is there, that message signal I have simplified. I have represented into one sinusoidal signal. Yes, very good evening. Yeah, good evening, Nikhil. Okay, so here theta is nothing but tan inverse 4 by 3. 4 by 3. Now, here we have to find out regarding the maximum value of the message signal frequency. That means our main motto regarding this particular message signal frequency, what is the maximum value that we can consider, so that we can avoid the slope overload distortion. Slope overload distortion. In general, the slope overload distortion occurs because of which case? See, while you are performing the delta modulation, we will consider the step size, right? We will consider the step size by considering the previous value and the current value. If the current sample value is greater when compared to the previous sample, we will consider the step size, we will increase, okay, or we will consider one step size plus, right? Suppose if the current sample value is less when compared to the previous value, we will consider minus delta. That means we are decreasing one step size, like that. So here ultimately the step size value, how much you are going to consider, so accordingly, suppose if you are considering optimized way, then there won't be any distortion at all, right? Because whatever the, with respect to step size you are getting, when you are getting the waveform regarding the message signal, so it will look like similar, right? But suppose if you are considering the step size more than actual requirement, then because of that, at that particular case you will get one kind of error. Similarly, if you are supposed to consider more step size, but due to some reason, any reason, if you are considering less step size, then because of that you are going to get one kind of noise or error, right? So now can you tell the slope overload distortion occurs in which case? Slope overload distortion occurs because you are considering the step size small when you are actually supposed to consider step size value more, but in that case you are considering the step size is very small. Because of that, the slope overload distortion occurs, right? Now if you want to see, just read the question. In order to avoid the slope overload distortion, okay, in some question they will ask in which condition the slope overload distortion occurs. Okay, that time the delta value is less, right? But here, to avoid the slope overload distortion, that means you have to increase the step size, right? Because this particular distortion occurs because you have considered, when compared to the optimum step size, you have considered very less, right? Now if you want to overcome this slope overload distortion, you have to increase the step size, okay? So now write the condition. The condition to avoid slope overload distortion. The condition to avoid slope overload distortion is delta by Ts. Now the step size value should be more, right? That's why we are considering like this. Okay, if you want, you can consider equality case also. Okay, delta by Ts greater than or equal to dm of t by dt. See here, if you observe simple logic, here m of t is what? Our actual message signal. That message signal we are performing differentiation operator. So whenever you are performing differentiation of any particular signal, actually you are using the operation differentiation, but that differentiation indicates in the real time. What is the physical significance of differentiation? Can you recall? Previously I have discussed regarding integration means, integration is nothing but area under the curve. Okay, Integration is nothing but area under the curve. Similarly, differentiation indicates which, or differentiation signifies what parameter? Can you recall? It is slope, right? Here differentiation term d by dt. d by dt indicates slope. Here d by dt indicates slope. Slope of here message signal, slope, okay. And here this m of t is the actual signal, but in the delta modulator, whatever the actual signal we are having, we are considering the samples. After that samples, with the help of delta modulation technique, whatever the sampled values we are having, we are quantizing in integer multiples of delta, right? So here after that delta modulation, so with respect to amplitude wise, okay, from one sample to another sample, only the step size increment. That's why here with respect to here difference here differentiation or difference. Suppose individually if you consider numerator denominator, you are having difference of message signal or difference of two sampled signals or two quantized signals, right? That difference will be delta. Okay, for the timing I have considered like modulus. If you want more strictly, you can consider modulus or magnitude. Okay, now one sample and another sample difference are separated by one sampling time interval. So that is the reason we have considered TS. Okay, I hope all of you are getting the clarity. So this is actual signal, this is after the quantization, right? If both are giving same values, that means there is no error at all. Okay, there is no error at all. So in this case, the slope overload error occur in general if you are considering the delta value very less when compared to the optimum level. That time you are getting slope overload distortion. If you want to overcome, you have to increase the step size. That is the reason I have put greater than or equal to, right? I hope all of you got the clarity. Okay, right. Now in this question, since they have given, step size as 2 millivolt and they have given the sampling frequency they have given, right? But here in this formula, we are having TS. We don't have directly Fs, right? Sampling frequency is Fs. How we can write? Here 1 by Ts, we can write it as sampling frequency. Yes or no? Yes, 1 by Ts we can write as sampling frequency greater than or equal to dm of t by dt. So now substitute the given values. Step size is 2 millivolts. Milli I am writing it as 10 power minus 3. And sampling frequency given as 2000 samples per second. Greater than or equal to d by dt. That means differentiation we have to perform. Okay, for this message signal, this is the actual signal, but after doing simplification we got like this, right? So 5 sin 2 pi fmt plus theta. 5 sin 2 pi fm into t plus theta. 5 sin 2 pi fm into t plus theta. Okay, right. Here 1000 you are having, here 10 power minus 3. So when you multiply, you will get 1. So 2 into 2, you are getting 4. 4 greater than or equal to. Here 5 is the constant, we can keep as it is. Next, derivative of sine term. Derivative of sine is nothing but cos. Cos 2 pi fm into t plus theta. After that you have to perform differentiation of this particular term. Here 2 pi fm is the constant, so you can keep as it is. Differentiation of t with respect to t, you will get 1. Now d theta by dt, where theta is what? Constant. So differentiation of constant is 0. Okay, so that term you can neglect. Now from here 2 times. Okay, so from here you are getting, say for example, this 5 and pi I am bringing to the left hand side. So you will get 2 divided by 5 pi. greater than or equal to fm into cos 2 pi fm into t plus theta. Okay, so up to here we got the relation like this, but in this question if you observe, in this question we are asking the maximum value of the message signal frequency, right? Maximum value of the message signal frequency. So here regarding cos, in the last class also I have mentioned the cos signal or sine signal varies between -1 and +1. Okay, so here consider regarding the cos signal maximum value, cos signal maximum value you can consider. So if you consider cos signal maximum value, so from there you are going to get 2 by 5 pi. So if you want, you can represent here like magnitude also, like that. From here if you are considering regarding cos, the maximum value you are going to get 1, right? So 2 by 5 pi greater than or equal to fm into 1. So from here, whatever the relation like this here we are having, we can represent in another way, right? So we can represent that fm less than or equal to 2 by 5 pi, fm less than or equal to 2 by 5. So all of you do the simplification of this one and mention your answer in the chart. You can use your mobile or you can use your calculator and do the simplification of this value, and you can mention your answer in the chart. I hope all of you will get the correct answer. I am giving some time, all of you give a try. Yes, I hope all of you are getting 0.127. 0.127 units are H. Now if you observe regarding the message signal frequency, you can consider any value less than or equal to 0.127 H. That means the maximum frequency that you can consider when you are considering equal to case. Yes or no? Right. So that means the maximum frequency of the message signal. Maximum frequency of message signal is equal to 0.127 Hz. 0.127 Hz. So the answer for this question is 0.127. Okay, I hope it is clear for everyone. Yeah, this is the next question. All of you give a try. Yeah, time up. Whoever solve this question, whatever the answer you are getting, you can mention in the chat. Okay. Whoever watching this particular session later, right? So after solving each and every question, you can mention your answer in the comment section. Okay. Right. So first, let us read the question. Here you are having one voice signal which is sampled at the rate of 8000 samples per second. Okay. Each sample is encoded into 8 bits using PCM, that means pulse code modulation. The PCM signal is transmitted into free space after modulation. Now determine the bandwidth of the modulated signal if the modulator used is. Actually this question is conventional question. Okay. So you have to find out the bandwidth of the signal in such a that in case 1 if you are considering the modulator as ASK, in case 2 if you are considering the modulator as PSK, similarly case 3 if you are considering modulator as FSK. So in each case you have to calculate the bandwidth. Okay, for the timing, this question instead of making as MSQ, okay, just to make the question simpler, I have kept in the conventional. Okay, since you don't have the options, it is you are having curious, right, whether your answer is correct or not. So just to keep some suspense, okay, and curiosity, for the timing I have kept this question as conventional. Even in the last session also we have discussed some questions are of MCQ, some questions are of MSQ, some questions are of NAT, and some questions are conventional. Whenever conventional question is there, you don't have any clue, right, guess which option will be correct, because you don't have options, right. Ultimately you have to solve the question, right. But whatever the conventional questions we are discussing either in the last class or in this class, this concept will help you, okay, in order to attempt the questions in the coming GATE exam, right. Of course in the GATE exam you never get the questions like conventional point of view. Okay, you will get either MCQ or MSQ or NAT. Okay, but whatever the concepts we are discussing, whatever the method of solving we are discussing, those are very much helpful for all of you, right, for your coming GATE exam. Okay, right. So just to keep the session more interesting manner, that is the reason I have kept all the possible variety of questions. And in fact, if you observe in the last class also and in this class also, we are discussing variety of questions and interesting questions, right. Yeah. So for this question, whatever the given data is there, first note down. So after that we will calculate one by one. Okay. So first of all, the sampling frequency is given, so that you can note down. Sampling frequency is Fs, which is nothing but 8000 samples per second. 8000 samples per second. And here number of bits used is 8 bits. So number of bits used 8 bits. For every sample 8 bits they have used. Now just observe these two. In fact, one of the earlier question also we have solved, okay, with the help of these two. You can observe closely. Here number of samples per second, here number of bits per sample. Now if you multiply these two, what will happen? Sample will get cancelled. You are getting bits per second. So whenever you are getting units bit per second, so that means that particular parameter is what? I hope all of you can answer. In fact, we have discussed in this session only one of the previous question. All of you please mention, whenever if you are getting units or bits per second, what is the name of that parameter? As the name implies, bits per second. In 1 second, how many bits you are transmitting? That is nothing but bit rate, right. Bit rate we will represent as R suffix B. Here R stands for rate and B stands for bit. How many bits we are going to transmit in 1 second? That is nothing but bit rate. So bit rate is nothing but N into Fs. Here N value is 8 and sampling frequency is 8000. So here 8 into 8 we can write as 64 and 1000 we can write it as kilo. And here you are getting units are bits per second. So for the timing I am writing in short BPS. Okay. So in some question they will represent bits per second, just like in one of the earlier question the way I have represented. In some questions in short they will represent BPS, whenever BPS means bits per second. Okay. So here K stands for kilo. In some questions they will represent M means mega, like that. Okay. So in 1 second we are transmitting 64K bits. That is the meaning. Okay. So as of now we got bitrate. Now in this question we have to calculate the bandwidth of the modulated signal. Okay, bandwidth of the modulated signal. Now let us consider case by case. Okay, here in case 1 you are having ASK, in case 2 you are having PSK. Okay, I hope all of you know the formula regarding bandwidth of modulated signal. Whenever you are using ASK or PSK, you are going to get the same bandwidth. Okay, the bandwidth of ASK modulated waveform or bandwidth of PSK modulated waveform, both are same. So here in case 1 and case 2 you are going to get the same answer. Bandwidth of ASK signal and bandwidth of PSK signal, both are same. What is the formula? Any guess? Bandwidth of ASK and bandwidth of PSK, you are going to get same. What is the formula? Yes, very good. 2 times bit rate. Here just now we got bit rate. What is the bit rate you got? Here you can substitute, multiply with 2. 2 into 64K. So 2 into 64 is nothing but 128 kilo. Here bandwidth, units are H. See here, if you observe, here BPS is nothing but bits per second. So that means in the denominator you are having second. Whenever in general frequency units are what? Per second only. In general you will represent frequency units are H. That is nothing but what? Reciprocal of time. So time units are seconds. So that means per second H and per second H, all are same. Okay. Whenever we are using the term rate, that time we will use per second. But whenever we are using the frequency or whenever we are using the term bandwidth, always the units will be in the order of H. Okay, right. Fine. Bandwidth of ASK, bandwidth of PSK, both are same. That is 128 kHz. Now we have to calculate bandwidth of FSK. Bandwidth of FSK, here you are having, see, this is the frequency when you have considered bit value 1. This is the frequency when you have considered bit value 0, right? So you are having two frequencies, F1, F0. Okay. So now the bandwidth of FSK formula is, see, whatever 2 times RB you got, you will get same parameter. But in addition to that, here we have to consider difference of these two frequencies also. Okay. So the formula is F1 minus F0 plus 2 times RB. F1 minus F0 plus 2 times RB. Okay, so in this question, F1 they have given 5 megahertz and F0 is 3 megahertz. 5 mega minus 3 mega plus 2 times RB, just now we got the value is 128K. Now 5 mega minus 3 mega is nothing but 2 mega, right? Here 1 unit you are getting in the order of mega, another value you are getting in the order of kilo. Okay, either both the values you can represent in the order of kilo or together overall value can represent in the order of kilohertz or you can represent in the order of megahertz. For the time being, I am converting the other parameter, other value into in the order of mega, right? So here we are already having 128K. So what you can do, multiply and divide with 1000. So that what will happen, numerator you are having kilo, here 1000. Together 1000 into 1000 is nothing but 10 power 6, that we can write as mega, right? So here 2 mega, first term we are copying as it is. Now 128 divided by 1000 is nothing but 0.128 and kilo into kilo is nothing but mega. So now you can add these two terms, simple, right? 2 plus 0.128 is nothing but 2.128. Here units you are getting in the order of megahertz. Whereas for ASK and PSK you got the bandwidth in the order of kilohertz, whereas FSK the bandwidth you got in the order of megahertz, Okay, so I hope it is clear for everyone. So whenever you are getting any question regarding bandwidth, directly you can solve by using the standard formulas. Okay, yeah, this is a very interesting question. All of you give a try. Here also this question is MSQ. Whenever I am mentioning choose the correct option or options, that means that question is MSQ. Either one option or more than one option can be correct. So here if you observe, two choices are related to entropy and two choices are related to information rate. So that means among these two, at most one option can be correct. Similarly, among these two, at most one option can be correct. Okay, so all of you give a try. I hope all of you know the formula regarding entropy and information rate. So all of you give a try. Yeah, whoever tried this question, you can mention your answer in the chart. For this question, either one option or more than one option can be correct. So whichever options you feel correct, you can mention in the chart. Right. So first let us read the question. Here you are having one discrete source which emits one of the four symbols. Okay, this particular source is going to produce four symbols, right? So every symbol here, if you observe, it is producing, emits or produces one of the four symbols. Okay, for every 200 microsecond. That means for every 200 microsecond, it is producing one symbol. Like that, four possible symbols we are having, right? So whenever you are having four possible symbols, okay, so to represent each symbol, we can use 2 bits. Okay, if you are representing one symbol with 1 bit, that means instead of symbol directly you can say bit. But here you are having 4 symbols, that means for representing each symbol we can use 2 bits. Okay, right. So for here totally you are having 4 symbols, right? Regarding those 4 symbols, okay, this particular discrete source is producing, right? So at what probability we are going to get each and every symbol, right? Regarding that, they have mentioned here. For the first symbol, the probability is 1 by 3. For the second symbol, 1 by 4. And third symbol, once again 1 by 4. And the last symbol is 1 by 6. Okay. So you are having total 4 symbols. For producing each symbol, the probability is like this. Okay, just perform the addition of all of this. How much you are going to get? 1 by 4 plus 1 by 4 is 1 by 2. And 1 by 3 plus 1 by 6. All of you give a try. Yeah, here just add all these probabilities, you should get 1. See, whenever you might have studied regarding the probability concept in your mathematics, right? So whenever you are performing any experiment like tossing a coin, so when you are tossing a coin, 2 possible outcomes like head or tail. Okay, so in general for getting either head or tail, the probability is like 0.5 only, right? 0.5 plus 0.5 is nothing but 1. Suppose if it is like biased coin, then for getting head, suppose if you are considering 0.4, so that means for tail, the probability is 0.6. Sum of all the probabilities equal to 1. Similarly, if you are tossing a die, there you are having like 1 dot, 2 dot, 3 dot, like that 6 dots are there, right? Up to 6 dots. So whenever you are tossing a die, you may get any possible outcome among 1 and 6, among 1 to 6, any possible outcome you will get, right? So sum of all the probabilities equal to 1. Similarly here, you are having one discrete source which is producing the symbols, right? With the help of this discrete source, you are getting 4 symbols, and for each symbol, here I have mentioned the probability like this. If you are adding all the probabilities, sum of all the probabilities equal to 1. Okay, here 1 by 4 plus 1 by 4 is 1 by 2. Okay, here 1 by 3 plus 1 by 6. For the time being, you can make here 2 by 6. 2 by 6 is nothing but 1 by 3, right? So 2 by 6 plus 1 by 6 is nothing but 3 by 6, which is nothing but 1 by 2. So 1 by 2 plus 1 by 2 is nothing but 1. So in that way you can verify whether the given data, in general they will give correct. Okay, but due to any reason, even if they are mentioning like that, okay, so you should make sure whether sum of all the probabilities is equal to 1 or not. Okay, of course, whenever you are doing any experiment, whatever the possible outcomes you are having, for each possible outcome you are getting some probability. So when you are adding all the probabilities, sum of all the probabilities is equal to 1. That is a basic property regarding the probability concept, right? Fine. Now in this question you have to choose the correct option or options, right? So here you are having 4 choices, out of which 2 choices are related to entropy and 2 choices are related to information rate. Okay, so first of all, with the given symbol probabilities, okay, let us calculate entropy first. Okay, so first of all, let us calculate entropy. entropy of the source, I hope all of you know the formula, h of x, or in simple words you can represent h, okay, both are same. Entropy of the source is equal to, you can represent h of x, or in simple words you can represent h, okay. Entropy equal to sum of, here summation I equal to 1 to n, probability into log 1 by probability. Here base value, how much we have to choose? This is very interesting. All of you please respond. Here logarithm base, how much we have to choose? Yeah, some of you are saying 10. Here we should not consider 10. Logarithm base 10 generally you will consider whenever you are using the term decibels. But here we are discussing this concept in the information theory, right? So in the information theory, this is a digital concept. Ultimately we will represent in terms of bits, zeros and ones, right? So whenever you are having bits, each and every bit you can represent only two possible values like 0 or 1. So that is the reason here base value is 2. In general, in the exam, students will consider base value 10, they will perform. But here if you are considering like that, that means your answer is wrong, okay. So here in the information theory concept, here base value is 2, okay, fine. So in this case, in the given question you are having 4 symbols, that means 4 probabilities are there. So here in this case n value is nothing but 4, right. So from here entropy is nothing but, for the first symbol probability is 1 by 3 log 1 by 1 by 3 is nothing but 3. Directly I am writing 1 by 1 by 3 is nothing but 2. 1 by 1 by 3 is nothing but 3. Okay. Next, second symbol probability, third symbol probability, both are same. 1 by 4. Probability is 1 by 4. Log 1 by 1 by 4 is nothing but 4 base 2. Similarly, the third term also same. 1 by 4 log 4 base 2 plus last symbol probability is 1 by 6. Here 1 by 6 log 6 base 2. See, you have to multiply probability with information, log 1 by probability. Okay, information is nothing but log 1 by probability. That information we are multiplying with the probability, that's all. Like that, what are the possible outcomes we are having for all the combinations we are performing that product, and then we are adding, that is nothing but entropy. Entropy in simple words, can you guess what is the other name for entropy? Entropy is nothing but average information. Simple logic. Entropy is nothing but average information. Entropy is nothing but average information. Average information. Okay, right. So here 1 by 3 log 3 base 2. So this value you will get 0.528 plus, see, like this you are having two terms, right? So you can consider this term, multiply with 2. So 2 into 1 by 4 log 4, I am writing it as 2 square base 2. Okay, so these two terms, if you are performing addition, I have considered this term, multiply with 2, both are same, correct? Next, last term, if you are calculating, you will get 0.431. You will get 0.431, right? Now, 0.528 plus here 2 times log 2 square base 2. This power 2 will come here, then 2 will get cancelled. Log 2 base 2 is nothing but 1. Directly I am writing. Then last term is 0.431. So just perform the addition of all of these three numbers. How much you are going to get, you can mention the chart. All of you just perform the addition. It is very simple. I have given 3 numbers. Just you have to perform the addition. Okay, what is the answer you are getting? You can mention the chart. Yes, I hope all of you are getting 1.959. 1.959. So this one we can make it approximate. Here if you consider third digit, that value is greater than or equal to 5. So you can add 1 to the previous digit. So from there you are getting 96. 5 plus 1 is nothing but 6. Okay. Now can you tell what are the units? What are the units? See, here I have mentioned average information. So here we are using symbols, right? So here how many bits for symbol on an average? In general, suppose in this case 4 bits are there. 4 symbols are there. So ideally speaking, like if all the symbols are having equal probability, then in that case for every symbol you are getting 2 bits. Okay. But since the probabilities are different, okay, so you are getting almost closer to that particular value. Okay. Here the average information is 1.96 bits per symbol. 1.96 bits per symbol. So here 1.96 bits per symbol, option A is there. So that one you can choose. That is the correct one. So option B is not correct. Option B is not correct. Okay. Fine. Now let us see regarding option C and option D, among these two which one is correct. Here information rate we have to find out. Okay. And here if you observe, here units you are having bits per second. See, in general if you are transmitting 1 bit or 2 bits, we will mention like how many bits we are transmitting in 1 second. But whenever you are having multiple bits or group of bits, we can call it as data or information. That is the reason we have mentioned in this particular question it is information rate. If you observe the previous questions, we have asked like for finding bandwidth or any other parameter, initially according to the requirement, in some questions we have calculated bit rate. Okay, how many bits we are transmitting, that is nothing but bit rate. So here bit rate, information rate, all are same only. In 1 second how many bits on average you are transmitting. Okay, right. So for finding this one, if you observe, as of now we got entropy. Here units are bits per symbol. Now you should get one more quantity or parameter. If you are getting like symbols per second, units, then symbol will get cancelled, bits per second you will get. Yes or no? Just like earlier we have used number of bits per sample and samples per second, sampling frequency. When we have multiplied both, from there we got bit rate. In a similar way here also you are getting. Okay. There we have used the term samples because in the digital communication chapter, what are the analog signal we are having, first we are considering the samples, after that those samples we are quantizing. That's why their terminology is number of bits per sample. Here in the information theory chapter, we are producing the bits. Okay. But whenever we are having like with the help of how many bits you are representing, so accordingly we can say, suppose if you are using 2 bits, that means we can produce 4 possible symbols. Similarly, if you are using 3 bits, we can produce 8 possible symbols, like that. In the combination of zeros and ones, you will get that particular pattern we are calling it as symbol. That's all. But whenever if you are using only 2 symbols, that means in that case symbol and bit both are same. But more than 2 symbols if you are using, in those cases symbol and bit slightly different. Okay. Suppose if you are having 4 symbols, that means on average each and every symbol you are representing with 2 bits, like that. Okay. Now just observe in the given data, from the given data, just if you read the first line, from there we can calculate how many bits we can produce for every symbol, or for every symbol how many bits we are going to represent, like that. Okay. So just observe here a discrete source emits one of the 4 symbols. Okay. For every 200 microseconds, we are producing one symbol, right? For every 200 microseconds we are producing one symbol. That means in 1 second how many symbols we are producing. So that means I am calling here symbol rate. Okay. So symbol rate, for the timing I am representing as R suffix S. Earlier I have represented bit rate, so R suffix B. Okay, here R suffix S. Symbol rate RS. In 1 second how many symbols we are transmitting. See, according to the given data, if you observe, we are transmitting every symbol for every 200 microsecond. For every 200 microsecond, one symbol we are transmitting. Now just take the reciprocal, that's all. Just take the reciprocal. 1 by 200 microsecond. 1 by 200 micro is nothing but 10 power minus 6. So from here what you are going to get, in 1 second how many symbols we are transmitting. Okay, so here you can represent the units, number of symbols that we are transmitting in 1 second. In 1 second. Okay, so here in the denominator 1 by 2 you can keep as it is. Here 100 into 10 power minus 6 we can write as 10 power minus 4. 10 power minus 4 units are symbols per second. Now 10 power minus 4 we can bring to the numerator, it will become 10 power 4. For the timing I am representing as 10 into 10 power 3, right. Denominator I am keeping 2 as it is. Here 2 5 times, 5 times. So that means you are getting 5k or otherwise 5000, your wish. 5000 symbols per second. 5000 symbols per second. See, whenever you are having one periodic waveform, okay, so from there you can calculate time period. If you are taking the reciprocal, you are getting the frequency, right. Similarly here, in the question they have mentioned that we are transmitting every symbol, okay, for we are producing one symbol for every 200 microsecond, right. So if you are taking the reciprocal, that means from there you are getting how many symbols on average you are getting per second. Okay, in 1 second with the help of that discrete source we are able to produce 5000 symbols. 5000 symbols. Okay, so here the units are symbols per second. Now if you observe here, units are bits per symbol. Now if you multiply both, from there you will get the units are bits per second. So now in this particular question the wording they have given information rate, because this particular question belongs to information theory concept. Okay, information rate is equal to entropy into symbol rate. Entropy into symbol rate. Okay, so entropy we got 1.96, and just now we got symbol rate as 5000. All of you do this simple calculation and tell your answer quickly in the chart. You can use your mobile or you can use your calculator, your wish. So all of you do the calculation and mention your answer in the chart. Yeah, it is very simple, right? How much you are getting? Yes, I hope all of you are getting 9800. 9800. Here units are bits per second. Units are bits per second. Now you can observe 9800. Yes, I have given in option D. So the moment if option D is correct, option C we can eliminate. So for this question, among option A, option B, option A is correct. Similarly, among option C and option D is correct. Okay, so whenever you are getting MSQ questions, there is a suspense, there is a surprise, right? Because you don't know really how many correct options are there. The moment if the question is MCQ, obviously among the 4 choices only one option will be correct. The moment if you are getting correct option, you no need to verify remaining options. But whenever you are solving any MSQ question, you have to verify each and every option whether it is really correct or not. If it is correct, then you have to mention. Okay, you have to select that particular option. If you are not selecting, say for example in this question, option A, option D are correct. Suppose you have chosen only option A in the GATE exam for this question. Suppose if you are getting same question in the GATE exam, say for example option A you have chosen, but option D you haven't chosen. Okay, so since in this question 2 correct options are there, suppose if the question weightage is 2 marks, Okay, because one correct option you have chosen, because of that you won't get 1 mark. Okay, that means partial marking is not there. And similarly, suppose example, here actually A and D are correct, but suppose you have chosen B and D, because B is not correct, because of that you won't get any negative marking. For MSQ there is no negative marking, there is no partial marking, but if you want to get the marks assigned for that particular question, whichever options are correct you have to select them. Okay, then only you will get marks assigned for that question. Okay, if you are choosing any wrong option, or if you are choosing the partial among the correct options, if you are choosing only some of them, then because of that you are not getting partial marking also. Okay, so all of these MSQ questions are very interesting. So during your GATE exam, whenever you want to attempt any MSQ question, so just read the question, just have a look at the given MSQ, and the moment when you have gone through the question, if you feel that you can solve that question in less time, then definitely you can attempt at that time only. But the moment when you look at the question, if you feel that it may require more time for solving that question, then you can hold that question at that time and you can solve that question at later point of time. Because say for example, in the MSQ question, whenever you are having 4 choices, suppose in one choice if they are asking one parameter to calculate, that means you are solving the given question how many times? 4 times, right? So definitely it will take more time. But in some questions you will get like this, 2 parameters only you are calculating. Okay, so with the help of one parameter, among these 2 you are deciding which one can be correct. Similarly, among the moment you are calculating this parameter, among these 2 you are deciding which one can be correct, like that. Okay, so and one more interesting thing, whenever they mention MSQ question, so for MSQ even single option also can be correct. Okay, so sometimes students will misunderstand that MSQ means minimum 2 options should be correct. No, not like that. MSQ means either one option or more than one option can be correct. So intentionally they can keep, whenever suppose only one option is the correct option, right? So the other 3 options they can give, like because of silly mistake, whatever the possible answers you may get, like that answers they can give in other 3 choices, right? Whoever do silly mistake, they may choose the other options which are not really correct, right? So because of that you are not getting partial marking, you are not getting negative marking also. But if you want to get marks assigned for that question, you have to choose whichever options really correct. Okay, that much care you have to take care regarding MSQ. Okay, fine. Now the last question regarding our GATE score booster session. Okay, so all of you give it a try. I will give some time for this question. All of you give it. This is the question regarding channel capacity. So all of you give it a try. Yeah, this is a simple question. What is the answer? This is a direct question based on the channel capacity, regarding channel capacity. So here first let us read the question. For the Gaussian channel, if the signal power and channel bandwidth, if both are doubled, then the channel capacity will become, in option A it is mentioned remains same, that means there is no change. In option B it is mentioned becomes 4 times. In option C it is mentioned double. In option D it is mentioned half. Okay, you have to choose among these 4 choices whichever is the correct, you have to choose. Okay. Right. So I hope all of you know the standard formula regarding channel capacity. Channel capacity is equal to C equal to D into log 1 plus S by N base 2. This is the formula regarding channel capacity by using Shannon-Hartley law, right? Channel capacity equal to, here B stands for bandwidth, okay, and S stands for signal power and N stands for noise power, okay. So here I am writing this expression like this: B into log 1 plus S is nothing but signal power, so I am keeping as it is. But here N stands for noise power. But this noise power, how we can write? Because in this question, if you observe, they haven't given any information regarding noise power, okay, but they have given the information regarding signal power. They have mentioned it is doubled. Similarly, channel bandwidth, it is doubled, right? So once if you know the channel bandwidth, from there you can represent the noise power as, say for example, the noise spectral density, okay. Here in this question it is mentioned Gaussian channel, right? So the Gaussian noise power spectral density you have to consider, right? So that is nothing but N0, and for whichever bandwidth you are considering, right? So if you are multiplying the bandwidth and power spectral density, from there you are getting the noise power, yes or no? See, the noise power spectral density, here just for reference I am mentioning noise power N is nothing but the noise power spectral density. We have to multiply with bandwidth, right? So the noise power spectral density, since it is given Gaussian, right? So that means Gaussian noise power spectral density we have to consider, that is N0, and bandwidth is B. So B into N0 or N0B, both are same, okay. So here if you observe, the power spectral density units you will get, see, just by observing here you are getting power spectral density. That means one term you are having power, so obviously units are what, but here we are mentioning density, that means per hertz, watt per hertz, whereas bandwidth units are hertz. So when you are multiplying these two, hertz will get cancelled, from there you are getting watts, that is nothing but noise power, simple, okay. Power spectral density, if you are multiplying with bandwidth, the range of frequencies over which the noise is present, right? So that noise power spectral density and bandwidth, if you are multiplying, from there you are getting noise power, right? So that's why I have directly written here. Fine. Now this is the formula. Here base value is 2. See, whenever you are having Gaussian noise power spectral density, that is constant. Here N0 is the constant, okay. Fine. So here in this overall expression, if you observe, B is the variable and signal power is the variable. N0 is the constant. Here 1 is the constant, 2 is the constant, right? Yeah. Now in this question, if you observe, if the signal power and channel bandwidth both are doubled, right? Say for example, initially we are having like this. This is case 1. This is the channel capacity for case 1. Fine. Now let us consider case 2. In case 2, I am considering channel capacity as C2 or C dash, you can consider, no problem. Okay, in case 2 we are considering C dash, okay. Now in this case, bandwidth will become B dash log 1 plus signal power will become S dash, N naught as it is, and bandwidth will become B dash base 2. And according to the given question, the channel bandwidth become double and signal power also become double, right? So when compared to case 1, they become double, right? So here B dash is nothing but 2B log 1 plus signal power become 2 times S, N naught we are keeping as it is. Next B dash is nothing but 2B. Here base value is 2. Here 2 will get cancelled. 2 will get cancelled. Now here 2 I am keeping as it is. Then B into log 1 plus S by N naught into B. S by N naught into B base 2. Now if you observe this expression and this expression, whether both are same or not, this part of the expression I am asking. B into log 1 plus S by N naught into B base 2. Yes, same expression you are going to get, right? So that means this entire expression we can write the channel capacity in case 1, right? So from here we can write the channel capacity in second case is equal to 2 times channel capacity of the first case. So that means the channel capacity become double, right? So the channel capacity become double. So option C is the correct one. Option C is the correct one. Okay, so I hope all of you got the clarity. See here in this question, the only twist is whether do you know regarding the noise power how to represent in terms of power spectral density and bandwidth. That is the only twist. Once if you know that one, this question is nothing, right? But here in the communication system subject, generally you will be having more number of formulas, right? But some students will feel that, sir, how we can remember so many formulas and all, right? So it is very simple. See, wherever required, try to remember the standard equations, standard formulas, but wherever not required, okay, don't try to mug up or by heart so many formulas unnecessarily. Just like in this particular session or previous session also, wherever possible regarding in terms of units, I have given the highlight or hint points. So just observe those one. So by performing what kind of operation you are going to find out one parameter, so with the help of that logic you can get the values, okay? So it's not necessarily that you have to by heart n number of formulas, not at all required. But whatever the formulas you are having in the communication system subject, you will get familiarity if you are solving good number of questions, right? So in the last session and this session together we have discussed good number of questions regarding communication subject. I hope all of you got the clarity and command over the communication system subject. And in addition to that, earlier we have discussed regarding the communication system subject, the excellent practice questions we have discussed in our YouTube channel. So regarding that, you can go through the playlist. If you already watched, it is excellent. By this time you might have got the confidence, right? But whoever not watched, okay, those lectures, or whoever not attended those lectures, so kindly visit our YouTube channel, IMS Great Academy YouTube channel, and go to the playlist regarding the communication system subject excellent practice question series. And similarly, I have discussed the recent previous year questions also. Some of the selected questions I have discussed in the last 10 to 11 years, right? In the descending order, like we started from 2023, then 2022, like that up to 2013 we have discussed, okay? So whoever attended those sessions, by this time you people got the confidence. So in order to further increase that confidence, we have here this gate score booster session is going to help, okay? Whoever due to any reason if you miss those sessions and all, no issue at all. Even now also you are having good amount of time before your GATE 2024 exam, right? So kindly watch that playlist also regarding GATE previous year questions of communication system subject, okay? You will get here in this particular series, in the yesterday session and today's session together we have discussed good number of questions. In addition, whatever we have discussed in these two sessions is more than sufficient, but still if you are having more time, just kindly watch the earlier playlist regarding communication system subject in our YouTube channel, right? So kindly go through excellent practice question series and go through the previous question series, okay? So from there you will get all of you I'm telling, you will get the confidence about communication system subject. In general, students will feel that communication system subject questions we will get very lengthy, how to solve the questions in the GATE exam in less time. But whatever the earlier series we have discussed. So just go through, you will get good command over the concept I have discussed based on the possibility, conventional approach and shortcut approach. So all these lectures definitely play a vital role for all upcoming whoever targeting GATE 2024 exam, right? So all of you will get benefits, so kindly watch those lectures in your free time. Okay, so not the least, here I am going to announce regarding our IMS GATE Academy. We are start enrolling regarding live online program. Whoever targeting GATE exam as 2025 or 2026, for all those students we are having live online program. So all of you whoever targeting for GATE 25 or 26, so kindly book the slot regarding free counseling session. Regarding this particular link is available in the description. So whoever enroll for this particular program, what are the features that you are going to get regarding this particular program? Here you are going to get 800 plus hours live classes, right? So just like in this GATE score booster session, you might have observed that whatever the questions we are discussing, we are not directly discussing based on the formula, but wherever required we are discussing the concept also, so that all of you whoever attending our sessions, they are getting the complete picture, right? So in a similar way, here this is the live online program. So here in this classroom, live online classes, here all our faculties will discuss each and every concept from basic level to the application level, and in order to get for all the students, in order to get the confidence regarding each and every concept, we will discuss the variety of questions, practice questions we will discuss, and previous GATE questions also will discuss, right? So from those questions, each and every student will get good command over the concepts and command over the subject as well. And in addition to that, for every subject, whoever enrolled for our live online program, we are providing for every subject theory book and exercise book. Here the specialty of our exercise book, in each and every chapter you will be having 3 levels of questions, like level 1, level 2 and level 3. So in every chapter you will be finding around 60 questions, okay? And whichever chapter with respect to GATE exam point of view, if it is less weightage, in that chapter only you will find only 30 questions in that chapter. Otherwise most of the chapters you will be having 60 questions. On chapter level you will be having 60 questions. You are getting great opportunity to solve good number of quality questions before you are appearing for your GATE 25 or 26 exam, right? And here in addition to that we are providing GATE question bank, which consists of 30 plus years. The specialty of our GATE question bank is based on the possibility for whichever questions it is required, we have provided the alternate solution and we have provided the key points, important note points, okay? So whoever solving our GATE question bank, they are getting great feel and confidence about the subject as per your branch, okay? And in addition to that, we are providing online test series. So here for every chapter we are providing one test, and similarly for every subject we are providing basic test, advanced test and multi-level subject test, okay? After that we are providing all India mock tests, okay? So whoever practicing exercise book questions and then GATE question bank, and after that whoever attempting these test series, each and every student whoever enrolling for our live online program, they are getting the confidence, they will get the confidence before they are going for GATE 25 or 26 exam, right? So here we are providing whatever the preparation you are supposed to do before you are going for real GATE exam in the year 2025 or 2026. Whoever start enrolling now, that means you people are having great amount of time, good amount of time you are having, so you can best utilize, because we are providing whatever you are supposed to prepare in order to get very good rank in the coming GATE exam in the year 25-26. We are providing all the whatever resources required, we are providing through our classroom, through our quality books, theory book, exercise book and GATE question bank, and in addition to that test series. And not the least, at our IMS GATE Academy we are having one unique feature, that is my plan session, right? So each and every student whoever enrolled for our live online program, they can get the proper guidance and study plan with the corresponding mentor. On every month they can book one my plan session slot, and they can get the proper guidance and study plan. And if any student is facing any challenge regarding their GATE preparation, they can discuss with the mentor and they can get the proper guidance to overcome their challenges. Okay, so kindly share this valuable information with all of your friends and juniors. Whoever targeting for gate 25-26, they can book the free counseling session. Regarding that one, the link is available in the description, or you people can directly contact to these two numbers. Okay, right. And one more update I am giving. So here we are having regarding IMS Gate Academy one group in the Telegram, right? So this is our Telegram channel, right? So regarding this particular link also available in the description. So whoever not yet joined our Telegram group, so kindly join whenever you are having free time. Okay, so if you are joining our Telegram group, what are the benefits that you are going to get? Say for example, currently the Gate Score Booster series is happening. It is free for everyone in our, which we are conducting in our YouTube channel, right? So like this, whatever the upcoming live events are there, regarding that updates, we will be sharing in this particular group, right? And all the faculties, after completion of each and every live session, whatever we are writing on the digital board during the live session, this particular lecture notes we are providing in the form of PDF. We are going to share right after the session over. We will share the lecture PDF in this particular group. Okay, and in addition to that, whenever we are conducting any seminar or webinar regarding career opportunities, that updates also you will come to know. And whenever job notifications are there regarding PSU or government job, you will get updated. And not but not the least, on daily basis we are going to provide one quiz question, so all of you can actively participate, and the very next day our faculty will provide the solution for that quiz question. So you are getting on daily basis one opportunity to learn something new, right? So it is a kind of quiz question or question of the day, like that. Okay, right. So kindly share this valuable information with all of your friends. Okay, so from here in this particular session and yesterday's session together, we have discussed variety of questions and interesting questions regarding communication system subject. Similarly, the students who are from EC, electrical and IN, previously I have discussed regarding network theory subject, Gate Score Booster sessions, 2 sessions we have discussed. There also we have discussed a variety of questions, interesting questions regarding the network theory subject. So kindly watch those sessions also if you not yet attended earlier. Okay, so from this Gate Score Booster series, all of you, as the name implies, the agenda of this series is to increase your marks in the coming GATE exam, right? So kindly attend. So kindly subscribe our channel if you not yet done, and click on the bell icon so that you will get instant notifications. So in the upcoming week we are having further Gate Score Booster sessions regarding EC branch, electrical branch, instrumentation branch, right? So as per your branch, so kindly attend the respective sessions in the live whenever it is happening. And due to any reason, if you are unable to attend the live session, no problem at all, you can watch the recorded lecture later. It will be available in the playlist. Okay, so I hope all of you got the confidence regarding communication system subject. So we'll meet you all in the next live session. Okay, thank you everyone.